Good morning, everyone. Today, we are here with another topic of business economics, and we are going to discuss about the production. So, the theory of production. Production involves transformation of inputs such as capital, equipment, labor, and laws, land into output, that is, goods and services. In this production process, the manager is concerned with the efficiency in the use of the inputs. That is called as a technical versus a economical efficiency. Now, there are two concepts of efficiency, and these are one is called as economic efficiency, occurs when the cost of producing a given output is as low as possible so that we can have maximum profit generation. And the second is called as a technological efficiency, occurs when it is not possible to increase the output without increasing the inputs. So you will see that basic production theory is simply an application of constraint optimization. Now, what are the constraint of the optimization? Labor, capital, land, technology. These are the constrained inputs that we have. And we have to see that the optimization usage so that the production can be increased. The firms attempt either to minimize the cost of producing a given level of output or to maximize the output attainable with a given level of cost. Both optimization problems lead to same rule for the allocation of inputs and choice of technology. So what are the production functions that we have? So production functions are labor, raw material, land, technology, time, capital. So let's see from the definition. A production function is purely technical relation which connects factors, inputs, and outputs. It describes the transformation of factors, inputs into outputs at any particular time period. So Q, which is our output, is the function of various inputs. And these inputs are labor, capital, raw material, land, time, and technology. For our current analysis, let's introduce and reduce the inputs of two. Let's reduce the inputs of two, that is capital and labor, and see what will be the impact on our output. So as you can see that this is a production table. At one side, where we have the units of K number of employed, and second start, we are having the output for the same. As you can see that here, level number 7, we are having 65 output quantity. At the rate of 6, we are having 64. And at the rate of 3 also, we can have here 64. Now, what does it say is that same quantity can be produced with different combinations of inputs. Example, inputs are substitutional to some degree. Right here, you can see that how much I'm producing 7 when I am having 2 number of people units are employed. Here I'm at the level of 6 units is being at the rate when I have 7 labor is employed. Then 3 units, if you can see, I'm producing 64 output when 6 labors are employed. So we can see that as I'm increasing the labor, I have seen that the production which I am looking for the optimization can also be reached. So there are short-term as well as a long-run production. In short run, some inputs are fixed and some variable. Example, the firm may be able to vary the amount of labor but cannot change the amount of capital. Whereas in the short term, we can talk about factor productivity versus law of variable proportion and law of diminishing returns. In the long run, all inputs become variables. Example, the long run is the period in which a firm can adjust all inputs to changed conditions. in the long run, we can talk about returns to the scale. So as you can see, short run changes in productivity and production. So we have the factor of factor productivity, units of K employed and output quantity. As you can see that I am increasing the labors, I am reaching at the higher number of quantity where K, which is my capital, is stable. 4 units I am applying, K is my capital, it is stable. So when one labor is employed, we are producing 24 quantity, but we are now employed 8 laborers with the fixed number of capital. So we are able to reach at the high quantity of output. How much quantity of Q change when the quantity of L is increased? So as I am increasing my labor at the same capital cost, we are increasing the output of my quantity. This is called as factor productivity. Now, the long run changes in the production that is called as a return to a scale, right? So what happened is the question is how much does the quantity of Q change when the quantity of L and K is increasing? What I told is in the long run, we always have the increase in the various variables. So here I can see that I have 1K or one is my capital invested and one only the labor. So you can see that I am only able to produce only 4 quantity. But in the longer run, if you can see that as I am increasing my capital also and my labor also, I can see a substantial growth into my output, right? At the end, if you can see that when I have employed 8 laborers and I have increased my capital also, I have reached at a higher output quantity. This is called as the long run production changes and the short term production changes. So, what are the relationship between total average and marginal product for the short run analysis? Total product is equal to total quantity of output. Average product is equal to total product per total input. And marginal product is change in quantity when one additional unit of input is used. So these are the important formulas that we have for total product, average product, as well as the marginal product. So we will continue this in the next lecture. Thank you so much.